All right, so I'm going to go over the answers to all the questions in this video, so you can see maybe where your misthinking is, what you need help with, so you can build your plan of where you're struggling, what you don't understand. So I'm going to really ask you to pay attention, to really think about it, to really try and figure out what is it about fractions that you're not understanding if you're struggling with this. Okay. All right, so if I look at the first question, it says, Alejandro, Benjamin, and Camilla are about to eat lunch, and they have 2 sandwiches to share. So 3 kids, 2 sandwiches. Letter A says, draw a picture to show how they could equally share, so they all need the same amount, the sandwiches. How much of a sandwich does each person get? Well, the very first thing I'm going to do is I'm going to draw 2 sandwiches. I'm just going to make them 2 rectangles. So this is sandwich 1, and this is sandwich 2. I know there are 3 people, okay, so each one is going, if I'm going to share this equally, I need to cut each sandwich into thirds and see if that helps me out. So now I'm going to label each one with a different letter. So these first 2 pieces are for Alejandro. These next 2 pieces are for Benjamin. And these last 2 pieces are for Camila. So each person got 2 pieces. You understand how many people you have or how much of the something that you need to divide into, and then you just divide it into those amount of pieces. If I had, anything, piece of paper, and I needed to divide it amongst 3 people, I would cut it into 3 pieces. If there was 4 pieces, I would need to cut it into 4 pieces. If there was 4 people that needed to have a sandwich, I would cut the sandwich into 4 equal pieces and give that to them. Okay? So now let's look at the total here. So I've cut each sandwich into thirds. There's 2 sandwiches, so there's 1, 2, 3, 4, 5, 6 thirds. There are 6 thirds, and each person is getting 2 of those thirds. So how much of a sandwich does each person get? Well, you could argue 2 different, well, no, yeah, they get 2/3 of a sandwich. They're getting 1/3 of 2 sandwiches, but for the question, how much of a sandwich does one person get, or each person get, they get 2/3 of a sandwich. Okay. All right, so the next one, it says, write an equation, number sentence, so numbers that equal something, involving addition, so it has to be addition, equation, to show, this should be show, to show how together these parts make up the 2 sandwiches. So if I think about the parts, I have this is a part, this is a part, this is a part. How did these 3 parts make up 2 sandwiches? Explain how the equation you wrote represents this situation. Okay. So here I have Alejandro with his 2/3. If I add that to Benjamin's 2/3, and I add that to Camilla's 2/3, that is going to give me 2 for 6/3, and 6/3 is the equivalent of 2, so that gives me 2 sandwiches. If I want to explain how the equation I wrote represents the situation, I take each child's part is 2/3. There are 3 children for a total of 6/3 or 2. Now the next one, it says write an equation. So same thing, equation involving multiplication. So not addition, to show how all the parts make up the two sandwiches. So this was an addition problem that shows how we get 2. So now we need to think of what's another way we can show this using multiplication. Okay, and so for that, what we need to do, excuse me as I drink some coffee there, maybe I'll edit that out. How many 2/3 do we have? We have 3 2/3. So we have 3 sets of 2/3, and that equals 6/3 or 2. That's the equation. And again, we have 3 sets of 2/3, which equals 6/3 or 2. All right, next one. Write an equation using multiplication to show the fraction of a sandwich each student gets. So this is different. It's asking here, it's wanting us to show the 2 sandwiches, so our answer is going to be 2. This one is showing the fraction, so our answer is going to have to be 2/3, right? Because we know that the kids get 2/3 of a sandwich. So how are we going to show this with multiplication? Well, I know we have 2 sandwiches, and I know that there are 3 kids. So let me think about this. 2 times 3 is 6. So that doesn't, no. Each kid doesn't get 6 sandwiches. Each kid gets 2/3. Oh, we have to, okay. We have 2 sandwiches and we're splitting that into thirds. We have 2 sandwiches. There's 3 kids. So we're going to multiply that by 1/3. To see what fraction that we need. So 2 times 1/3 equals 2/3. So let's think about this 2 times 1/3. If we go back up to our picture, each sandwich is split into a third, right? Or into thirds. And each person is getting 2/3 of the sandwich. But if we're looking at the whole entirety of the 2 sandwiches, and that whole entirety is 6/3, right? All of this together is 6/3. They are getting 1/3 of the 2 sandwiches. They're getting 2/3. 2/3 is 1/3 of 6/3. Okay? So that's how we can explain it down here. 2 of, so out of the 2 sandwiches, and maybe I should rewrite this better. We have 1/3. Each person is getting 1/3 of 2 sandwiches. And that equals 2/3 of the total. So they're getting 2/3 of a sandwich. 1/3 of the 2 sandwiches, right? We have 2 sandwiches and they're getting 1/3 of the total. But when we look at each sandwich, they're getting 2/3 of that sandwich. This one's a little more complex to kind of get down and understand. So if you have questions about this one, please do ask. Explain how this equation you wrote represents the situation. There are 3 kids, so each child is getting 1/3 of the 2 sandwiches, which equals 2/3 of 1 sandwich. All right. And lastly, write an equation using division. So again, we're doing an equation, but this time using division, to show the fraction of a sandwich each student gets. So if I have 2 sandwiches and I'm going to divide those into 3 parts, and that's going to give me 2/3. So again, I have 2 sandwiches. We have to divide equally by 3. A fraction is unfinished division. What I mean by that is 2/3 is a division problem. 2 divided by 3, which is equal to, if you know your decimals, 0.6. So fractions are unfinished division. So it's just a division problem. So if we have 2 sandwiches and we have to divide them into 3 equal parts, we just do 2 divided by 3, which in a fraction form is 2/3. So fraction is unfinished division, thus 2 divided by 3 equals 2 divided by 3. All right? Okay, so those are the answers for the first part. What's next? I think. Okay. Here's the second problem. It says there are 2 design proposals for a new rectangular park in town. In design 1, again, this was the mistake where we should have 3/4 of the area of the park is going to be a rectangular grass area, and 1/2 of the grass area will be a rectangular soccer field. In design 2, only 1/2 of the park is going to be a rectangular grass area, and 3/4 of the grass area will be a rectangular soccer field. Which design, 1 or 2, will have a bigger soccer field? Explain your answer. Draw a diagram that can be used to compare the size of the soccer field in the 2 designs. Label the values 1/2 and 3/4 on the diagram. All right, so here is the new park, Park 1. Park 1 says 3/4 of the area of the park. 3/4 would do 1/2. 1/4 right here. All right, so this 3/4 of this is going to be where's my head? 3/4 of this is going to be a grass field, okay? So we know 3/4 of this is going to be a grass field. Now, from this, 1/2 of it is going to be a soccer field. So that's design 1. Design 2 it says only 1/2 of the park, so following the same schematic, 1/2, is going to be a rectangular grass area, so this is 1/2. But of that, 3/4 of that grass area, somewhere around here, is going to be my soccer field. Which one is bigger? I mean, that one looks wider, but this one is taller. And here it says only. So does that mean this one's going to be bigger? I wonder. But see, like this one, I know. Because this, right? I don't know. Maybe I didn't draw this well. But still, wait, what's the, for area of something, we multiply, right? We multiply length times width. So this, let's think about that. So this area is 3 times 1 is 3. 4 times 2 is 8. So this area is 3/8 of the entire rectangle. Okay. So this area is 3 times 1 is 3. And whoa. Interesting. So they're the same. They're the same. So design 1 and 2 are the same. They're each 3/8 of the entire rectangle. That's fascinating. I wonder if I could prove that with measurements. What do you think? So let's think about this. Let's make it fairly straightforward. Why don't we turn this? Okay, let's do this. Let's do this. Let's change it. And I'm going to say there are 2 designs for a new rectangular park in town. Okay, so it has to be a rectangle. I do like, you know, our powers are numbers ending in 0. But let me think about what is... Okay, let's do this. Let's try this out. So now I'm going to make a rectangle. So this is the new park. But I'm going to say it's 20 by 10. Okay? So each one is going to be 20 by 10. So this first park, it said 3/4, right? And then half. So if we want to think what this here, 3/4 of 20, 20 times 3/4 equals 64ths, or that can be, what, 15, right? Yeah, 15. So this value would be 15, and this is going to be half, so this value is 5. So if we're looking at this area here, that would be 15 times 5, 75. So this area is 75 square units. So again, if we do the same thing down here, so it's only a half, and then this is 3/4. We're getting into decimal place there. I guess I should have thought about that. Anyway, let's see this through. So half of 20 is 10. 3/4 of 10 is 30/34ths. Let's see this through. 34ths. So then 10 times 30/34ths. That is equal to 300/4. And if we divide 300 by 4, 7, 28, 205, 75 square units. Awesome. So that we just proved it. We proved that this area and this area are the same using actual numbers. Awesome. Awesome sauce. I always like when things work out. Awesome. Numbers are what, guys? Awesome. Cool. All right. Next problem. Lucas had a calculator that will only display numbers less than or equal to 999,999,999,999. Again, if we don't know what that means, there's a calculator, right? It has numbers here, buttons. And this is the display, and on his display, that's it. That's the largest number. He can't, there's no more place value. This is the biggest number he can get. Okay, and so what this is asking is which of the following products. So if he types in 999,999,999 times 792, is the answer going to be able to be displayed on this? So does the number get bigger? Okay. If we know our multiplication numbers, or theory and all that stuff, if we understand our value system, we know that any number multiplied by any number greater than 1. So here we go. Or let's look at these values. So if we take 2 and we multiply it by 1, we're going to get itself. If we take 2 and we multiply it by something bigger than 1, we get something bigger. If we take 2 and we multiply it something less than 1 and greater than 0, like a half, we get something less than what we started with. So this is multiplication. This is huge for you to understand. We multiply something by 1, it stays the same. By something more than 1, it grows. By something less than 1 and greater than 0, it shrinks. Actually, probably less than 0. Anything less than 1. Because even if you go into negative town, real quick, ignore this if you want to. So like 2 times negative 1, that's equal to negative 2. And negative 2 is much less than 2. So so when we multiply by 1, the product stays the same. Let's make this better. So if I have a product and I multiply it by 1, it equals the product. If I have a product and I multiply it by something greater than 1, it equals greater than the product. And if I have a product and I multiply it by something less than 1, it's going to equal less than the product every time. So if we know that, it's very straightforward. He can't do this because 792 is more than 1. Half is less than 1, so he can certainly get that product. 15/4 is more than 1, so he can't do that. 0.67 is less than 1, so he can do that. Okay? So there you go. So we've proved it. All right, so that's this problem. And on to the last one. Lovely. All right, so last problem here. So it says a package contains 4 cups of oatmeal. There is 1/3 cup of oatmeal in each serving. How many servings of oatmeal are there in the package? So some background if you don't know. When we're talking about cooking, I'm not the best drawer in the world, but sometimes you'll see a contraption like that, a measuring spoon or measuring device, and this one is 1 cup. Maybe you'll see another one. That would be half a cup. And then another one. 1/3 of a cup. Okay? So they have these measuring tools to help you when you're cooking. So this idea of cups is a measurement. Okay? Cup. The idea of a serving. When we're eating, there are recommended servings. So if you look on recipes, it might say for 1 serving of oatmeal, you need 1/3 cup of oatmeal, 1/4 cup of milk, heat and enjoy, or something like that. So what this is telling you is it's giving you the recipe, and it's saying, well, part of the recipe. It's saying 1/3 cup of the oats in here is used to make 1 serving of oatmeal. Okay? All right, so that means we have 4 of these cups inside the package, and 1/3 of each of these cups equals a serving. All right, so if I draw my oats package here, okay, so here's my oats package. So inside that oats package, it has 4 cups. So this is 1 cup, 1 cup, 1 cup, and 1 cup. So that equals the 4 cups that the package has. So this is my package of oatmeal. All right. Now, it's saying that 1/3 of a cup equals 1 serving. And it's asking me how many servings do we have? So if I split each cup into thirds. So this is 1/3 of a cup. This is 1/3 of a cup. This is 1/3 of a cup. And I keep doing that. So now I've split all of these into thirds. So now it's asking me how many total servings can I get out of this package. And so if each cup is a serving, or each third of a cup, that means I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 servings of oatmeal. And I could say 12 servings of oatmeal in a 4-cup package. And if I wanted to use the algorithm to show that, I would say there are 4 cups of oatmeal, and I'm going to divide each of those cups into thirds to see how many total thirds there are in 4. And if we take the reciprocal, so what that looks like, we change it to multiplication, which equals 12. All right, so that checks our work. So this is a good use of the algorithm, is checking your work. Just doing the algorithm doesn't show any knowledge. It shows nothing. It shows you can just follow steps and get an answer that you have no idea if it's right or not. Supporting your answers with algorithm, that shows a strong mathematical mind, a strong mathematical concept, and is what should be done, okay? If you have questions, you can comment in the Google Classroom where the video is stored. And at this point, what you need to do is you need to go through. If you need to rewatch the videos, rewatch them. Really think about what is your question that you're wondering about. What doesn't make sense to you? What are you struggling with? Okay, because then we need to make a plan. So what do you need? What questions do you have? I would start with that. List some questions. What are you wondering about? What don't you understand? And don't say, oh, I don't understand anything. That's bogus. That's useless. It's pointless. There's no point to saying I don't understand anything. You have to understand some stuff. Okay, so go back, think about it. What questions do you have? Okay, and then we'll plan from there. All right. So again, make up some questions. Grade yourself. How do you fit? What did you do on this one? So I'll go through that again. What were the answers? Yeah, I didn't really go through that, how you're going to grade yourself. So here, depending on how you did on this one, so you see that this standard 5NF2, which is talking about adding fractions together, those are questions A and B. So depending on how you did on A and B, you either show no evidence of learning, if you're just completely way off, not even close, or you didn't do it. You're approaching, maybe you made some mistakes with your addition, or like you had an equation, you had some fraction formed down, you're approaching. If you did it like I did, you're meeting it. If you did it better than I did, it's just wow, it's just completely different and still right and new math, then you would be exceeding at this point. For 5NF4A, which is about multiplication, that's C and D, and then 5NF3 is this one. All right, so look at each question and grade yourself as to where you think you fit. For this one, it's just one standard, meets the whole thing. Again, what did you do? Probably if you did what I did and proved it with numbers, that would be exceeding. If you just did this and said they were equal, they would be meeting. Okay. No evidence, you didn't do it. Approaching, you're getting some of it down. Again, for this one, I proved it. This would probably be exceeding, the idea of writing out a generalization. That would be exceeding for this one. Meeting with getting it right and knowing why. Okay. And again, this one is for 5NF7. So where do you fall on this when it comes to, this would be an example of meeting. Exceeding, I don't know what exceeding would look like. Maybe you can try and figure out what exceeding would look like. All right, so good luck. God bless. See you.